Fundamentals of pipeline construction. What is pipeline construction? Pipeline construction is a complex process that involves the installation of underground pipes designed to transport various materials across long distances. The construction of pipelines has become increasingly important in recent years due to the growing demand for oil and gas, as well as other materials such as water and chemicals. In order to ensure the safe and efficient transportation of these materials, it's crucial that pipeline construction is done correctly. There are several key factors involved in pipeline construction, including planning, material selection, design and engineering, safety regulations compliance, environmental impact considerations, and ongoing maintenance. In this video, we will explore each of these aspects in detail to provide readers with a comprehensive understanding of the basics of pipeline construction. Planning and design. Planning and design are crucial aspects of pipeline construction. The process involves several stages, including site selection, route surveying, environmental impact assessment, and material selection. During the planning stage, engineers must consider factors such as terrain, soil composition, topography, potential hazards, such as natural disasters or man-made obstructions, accessibility to transport routes and facilities for installation. Once the planning phase is complete, engineers will proceed with designing a comprehensive blueprint of the pipeline system. This includes determining pipe size and thickness based on anticipated flow rates and pressure requirements. Designers will also select materials based on durability in different environments, e.g., corrosion resistance in seawater, and various stressors such as temperature fluctuations or shifting ground conditions. Blueprints, permits, environmental assessments. Blueprints, permits, and environmental assessments are essential elements in the process of constructing pipelines. Blueprints provide a detailed plan for the pipeline's design and layout, including the location of valves and fittings. These blueprints must be accurate to ensure that construction proceeds smoothly without any errors. Permits are required by federal and state agencies before pipeline construction can begin. These permits typically require environmental assessments that evaluate the potential impact on wildlife habitats, water quality, and other natural resources. The assessment helps mitigate potential damages on ecological systems through proper planning or changes in construction methods. Environmental assessments ensure that pipelines do not negatively affect ecosystems or human settlements near the proposed route. They also help identify appropriate measures to prevent soil erosion or sedimentation during construction. By following these procedures, pipeline companies can ensure their projects meet regulatory requirements while minimizing environmental damage during all stages of development. Materials and equipment. Materials and equipment are crucial components of pipeline construction. Pipeline construction involves the use of various materials such as steel, plastic, and concrete. These materials are used for different pipeline types, depending on their intended use and location. For example, plastic pipes are commonly used for water pipelines in residential areas due to their flexibility, while steel pipes are often used for oil and gas pipelines due to their durability. Proper selection of materials and equipment is essential in ensuring a successful pipeline construction project. The ability to choose the right material and tool is critical to achieving a durable structure that can withstand environmental conditions and last longer without frequent repairs or replacements. It is therefore important that pipeline contractors invest in quality materials and maintain their equipment regularly to ensure optimal performance during every project execution stage. Types of pipes, welding machines, safety gear. When it comes to pipeline construction, it is important to understand the different types of pipes that are used. The most common types of pipes include steel pipe, PVC pipes, ductile iron pipes, and concrete pipes. Steel pipes are commonly used due to their strength and durability, while PVC pipes are often used for their flexibility and resistance to corrosion. Welding machines play a crucial role in pipeline construction as they join sections of pipe together with high-quality welds. There are different types of welding machines available, including stick welding machines, MIG welding machines, TIG welding machines, and flux cord arc welding (FCAW) machines. Each type has its own unique advantages depending on the specific needs of the project. Safety gear is also an essential part of pipeline construction as workers need to protect themselves from potential hazards such as falling objects or exposure to hazardous materials. Some common safety gear includes hard hats for head protection, safety glasses for eye protection, earplugs for hearing protection, gloves for hand protection, and steel-toed boots for foot protection. Additionally, respiratory masks may be required when working with certain chemicals or substances that present a risk of inhalation. Oil and gas companies may also require fire-resistant clothing for oil and gas contractors. Overall safety should always be a top priority when working on any construction project, including pipelines. The construction process of pipelines. Initial staking and marking of proposed route. Once a pipeline route has been selected, the next step is to mark and stake out the proposed path. This is done to ensure that the construction crew knows exactly where to excavate and lay the pipe. The process involves marking the center line of the proposed pipeline route with wooden stakes, which are driven into the ground at regular intervals. After marking out the center line, surveyors will use specialized equipment to accurately measure and map out any changes in elevation, curves or bends in the terrain along the route. This information will then be used by engineers and designers to create detailed plans for constructing each section of pipeline. Clearing of right-of-way. The first step in clearing a right-of-way is to conduct a survey to determine where the pipeline will be installed. This survey helps identify any structures or natural features that may need special attention during the clearing process. Once identified, these areas are marked off so they can be avoided during land disturbance activities. After marking off sensitive areas, crews begin removing trees and shrubs along the right-of-way using heavy equipment like bulldozers and excavators. The cut vegetation is then either chipped or hauled away from the site. The cleared area must be free from debris so that it can be easily accessed by construction personnel for further work such as trenching and laying pipes. Spotting lines. One call, dig test 811. Spotting lines are a critical aspect of pipeline construction. These lines are used to mark the location of underground utilities and other potential hazards that may be encountered during the excavation process. One call, dig test 811 is an important service that helps contractors and homeowners identify and locate these lines before any digging occurs. The One Call Dig Test 811 system works by connecting contractors and homeowners with local utility companies, who can then provide information about the location of their underground pipes, cables, and other infrastructure. This service is essential for preventing damage to these utilities, which can result in costly repairs, service interruptions, or even safety hazards. Mechanical excavation, trenching. Mechanical excavation trenching is a common method used in pipeline construction. This process involves the use of heavy machinery to dig trenches and remove soil for laying pipelines. The machines used for mechanical excavation trenching include backhoes, excavators, and trenchers. One advantage of using mechanical excavation trenching is that it is faster than manual digging methods. It allows for the completion of more work in less time, making it an ideal choice for large-scale pipeline projects. Additionally, this method provides precise and accurate cuts that enable pipelines to be laid at consistent depths. Stringing pipe. Stringing pipe is the process of laying out and positioning sections of pipeline to be welded together. It involves uncoiling, aligning, and fitting the pipes into place according to predetermined plans and specifications. The stringing process is a critical step in pipeline construction, as any misalignment or incorrect placement can result in costly errors down the line. During the stringing process, workers use heavy machinery such as cranes and forklifts to move each section of pipe into place. They also use specialized tools like clamps, chains, and supports to hold the pipe steady during welding. The goal is to create a straight line that will allow for efficient fluid flow through the pipeline. Properly stringing pipe requires a skilled workforce with experience in pipeline construction. Workers must have knowledge of safety protocols and take precautions against potential hazards such as falling objects or leaks from improperly aligned pipes. Pipe welding and joining. When it comes to pipeline construction, welding and joining are two critical processes that ensure the overall strength and durability of the pipeline system. In pipe welding, a variety of methods can be used, including gas tungsten arc welding (GTAW), gas metal arc welding (GMAW), shielded metal arc welding (MAW), and flux cord arc welding (FCAW). Each method has its own advantages and disadvantages, depending on the type of material being welded, the thickness of the pipe wall, and other factors. There are several key steps involved in the process. These include cleaning and preparing the surfaces to be welded, selecting appropriate filler materials based on the specific materials being joined together, ensuring proper alignment between pipes or sections of piping prior to welding, and monitoring temperature and other variables during the actual weld process to prevent defects or weaknesses in the finished product. Joining pipe is another important aspect of pipeline construction. In some cases, pipes can be joined using mechanical couplings or flanges. However, when creating a seamless structure is required for optimal performance or safety reasons such as underground pipelines carrying hazardous liquids like petroleum products and gases, then joining techniques such as butt welding may be necessary. Whatever method is used for joining pipes together during a pipeline construction project must ensure that there are no leaks in any part, along with stability against environmental conditions such as soil movement, which might affect integrity of the pipeline over time. Lowering pipe. Lowering pipe is an essential step in pipeline construction. It involves the careful and precise lowering of pipes into trenches or other underground structures. The process requires a team of experienced professionals who understand the various techniques needed to lower pipes safely and efficiently. One common method for lowering pipes is using a crane or other heavy machinery to lift and position the pipe over the trench. Once in place, workers will guide the pipe down into the trench while ensuring that it stays level and secure. Additionally, backfilling material may be added around the pipe to provide additional support. Hydro testing. Hydro testing is a crucial process in the construction of pipelines. It involves filling the pipeline with water and pressurizing it to check for leaks, cracks, or other defects that could compromise its integrity. This test is usually conducted after the pipeline has been welded and before it goes into operation. During hydro testing, the pressure inside the pipeline is increased gradually until the desired level is achieved. The pressure is then maintained for a specified period while inspectors monitor for any signs of leakage. They may use various techniques such as visual inspection, ultrasonic testing, or magnetic particle inspection to identify any defects. If any defects are found during hydro testing, must be repaired before the pipeline can be put into service. This ensures that the pipeline meets safety standards and can transport materials efficiently without causing harm to people or damaging property. Overall, hydro testing plays a critical role in ensuring that pipelines are constructed safely and operate effectively for many years to come. Backfill and compaction. Backfill and compaction are two important processes in pipeline construction. Backfill refers to the process of filling the trench with soil or other materials after the pipeline has been installed. The backfill material should be properly selected and placed in a manner that ensures that it does not damage the pipeline. This is because poor backfilling can cause future problems such as settlement, uneven loading, and deformation of the pipe. Compaction, on the other hand, is done after backfilling to ensure that the soil around the pipe is stable and free from voids. Compaction helps to distribute loads evenly around the pipe, which prevents settling or sagging of the pipeline over time. There are various methods used for compaction, including tamping, rolling, vibrating, or jetting, depending on project specifications. It is important to note that proper backfilling and compaction practices are essential for ensuring longevity of pipelines and preventing failure due to deformation or settlement issues caused by poorly compacted soils or faulty backfill materials. Final thoughts. In conclusion, pipeline construction is a complex process that requires careful planning and execution. The building of pipelines involves several stages, including route selection, land acquisition, design and engineering, construction and commissioning. Each stage requires specialized skills and expertise to ensure the pipeline's safety, reliability, and efficiency. When constructing pipelines, it is essential to adhere to regulatory requirements and industry best practices to mitigate any potential risks associated with these structures. Safety measures such as regular inspections, maintenance, and monitoring are critical in ensuring that pipelines remain functional throughout their lifespan. If you have any questions, comments, concerns, please leave it in the comments section down below. If you like this video, please like, share, and subscribe. See you in the next video. Disclaimer: Project Powerhouse assumes no responsibility or liability for any errors or omissions in the content of this video. The information contained in this video is provided on an as-is basis with no guarantees of completeness, accuracy, usefulness or timeliness. Thanks for watching.